Welcome to this Any Excuse for a Chemistry Experiment video. This required practical is only for you if you're taking your chemistry GCSE, not the double award exams. However, you will need to know the experiment and the related calculations. Determination of the reacting volumes of a strong acid and a strong alkali. Also, determining the concentration of one of the solutions. We will go through the experiment, the scientific principles, and the exam style questions. Feel free to jump to the bit that you need or watch it through. To be confident with this required practical, we must be confident with the procedure, recording the data, and calculating concentrations of solutions. If we keep this in mind, we'll be okay. This required practical is a neutralization reaction between a strong acid and a strong alkali. There are two options for the acid and the alkali, either using an acid that dissociates one hydrogen ion, for example hydrochloric acid, HCl, or an acid that dissociates two hydrogen ions, for example sulfuric acid, H2SO4. The same is true for the alkali, either an alkali that dissociates one hydroxide ion, for example sodium hydroxide, NaOH, or an alkali that dissociates two hydroxide ions, for example calcium hydroxide, Ca open brackets OH close brackets 2. The experiment. We need to be confident with the names of the equipment, the formula of the acid and the alkali, and the procedure. We will need a burette, conical flask, white tile, indicator, either phenolphthalein, methyl orange, or litmus solution. You'll need the acid, your alkali, and a pipette. We need to clean the burette with some deionized water. We then rinse with a little of the acid. Fill the burette with the acid. Record the volume to a precision of 0.05 centimetres cubed. If it's on the line, the volume will end in a 0. For example, 1.50 centimetres cubed. If the base of the meniscus is between the lines, the volume will end in a 5. For example, 1.55 centimetres cubed. Stand the conical flask on a white tile below the burette. Clean the pipette with deionized water, then rinse with a little of the alkali. Fill the pipette to the marked volume, 25 centimetres cubed in this case. Pour the volume into the conical flask. Add a few drops of the indicator, make a note of the colour. We're now ready to carry out our first titration, a rough or initial titration. Add 5 centimetres cubed of the acid to the conical flask. Swirl. Look for a permanent colour change in the indicator. If there's no change, repeat until there is a permanent colour change. Make a note of the colour, record the volume. Subtract the start volume from the finish volume. This is your end point. You know that neutralization must have happened between your volume and 5 centimetres cubed before. We're now going to complete as many titrations as it takes to get two concordant results. These results will either be 0.1 or 0.2 centimetres cubed. You'll be told this in the exam. Refill the burette with the acid, record your start volume. Pour away the solution in the conical flask, measure another 25 centimetres cubed of alkali and pour it into the conical flask. Add a few drops of the indicator. Pour the acid into the conical flask up to the last point when the indicator didn't change. Swirl the conical flask so the solution is well mixed. Open the tap so the burette is slowly dripping. Continue swirling until you get a permanent colour change. Stop the tap at this point. Record the finished volume. Subtract the start volume from the finished volume, and this is your end point. We are going to repeat this until we get 2 concordant results. We've got 3 choices. Phenolphthalein, this is going to go pink in the alkali and goes colourless. We want methyl orange, this will be yellow in the alkali but goes red. Or litmus solution, this is blue in the alkali but goes red. Let's have a closer look at the science. During a neutralisation reaction between an acid and an alkali, we make a salt and water. You might be asked to express this as an ionic equation. The important ions involved are the hydrogen ion from the acid, H+, and the hydroxide ion from the alkali, OH-. This gives us our reactants. When these ions interact with each other, they make water, H2O. H+ plus OH- gives us H2O. Next, we need to be confident with the terms moles, volume in decimeters cubed, and concentration. Moles. This is a unit of measure to describe a quantity of particles. There is more you need to know about moles, but not in this titration video. Volume. We measure volumes in decimeters cubed. Deci means 1/10. So a decimeter is a tenth of a metre, or 10 centimetres. 1 decimetre cubed can also be described as 1,000 centimetres cubed. Finally, concentration. This describes the number of moles of a substance dissolved in 1 decimetre cubed of water. The units are moles per decimetre cubed. The main purpose of a titration is to find the concentration of a solution by a neutralisation reaction. In our experiment, we know the concentration, the volume we've added, and the name of our acid. We also know the volume and the name of the alkali, but not the concentration. Let's work out the concentration. We do this in 5 steps. Step 1, the balanced symbol equation. Sometimes this is given to us in the exam, but sometimes we'll have to work it out. Here it is. H2SO4 plus 2 NaOH goes to Na2SO4 plus H2O. Step 2, the ratio of the acid to alkali. We have 1 mole of acid reacting with 2 moles of alkali. Step 3, how many moles of acid reacted? We need the calculation moles over volume is equal to concentration. We need to know the volume of acid. Remember to divide this by 1,000 to convert the units to decimeters cubed. And the concentration, we're going to have to rearrange that equation now. We need the volume multiplied by the concentration to give us our moles. Step 4, we now need to know how many moles of alkali reacted. We use the ratio to calculate the number of moles of alkali that was needed to neutralise the acid. In this case, we had 1 mole of acid was neutralised by 2 moles of our alkali. So, what we're going to do is we take our moles of acid and we multiply it by 2. This is going to give us our moles of alkali. Step 5. What is the concentration of the alkali? This is the question that will be in the exam. We now revisit the concentration calculation. Moles divided by volume is equal to concentration. Exam tips. I've seen 3 types of question for this required practical. Number 1, tell me the procedure for this experiment question. The student has X volume of sodium hydroxide of unknown concentration. The student used X volume of 0.2 moles per decimeter cubed of hydrochloric acid. Describe the plan for the experiment. You should include the name of a suitable indicator and the colour change you will see. Question number 2. calculate the volume and the concentration of the unknown solution question. Calculate the volume of hydrochloric acid from these 4 endpoints. Use only the concordant results. Concordant results are within 0.01 centimetres cubed. Use this value to calculate the concentration of the acid. 25 centimetres cubed of sodium hydroxide with a 0.40 moles per decimetre cubed was needed. And the third question, the strong acid and ionic equation. Give a definition of a strong acid. Write the ionic equation for a strong acid and a strong alkali. Include state symbols. The first question is likely to be a 6-mark question. There will be marks available for the correct names of the glassware, a methodical plan and the correct information about the indicator. We're going to clean the glassware, fill the burette with the acid, stand the conical flask on a white tile below the burette, fill the pipette with the alkali, pour the volume into the conical flask. Add a few drops of the indicator. We've got 3 choices. Phenolphthalein, this is going to go pink in the alkali and goes colourless. We want methyl orange, this will be yellow in the alkali but goes red. Or litmus solution, this is blue in the alkali but goes red. Add the acid dropwise, stir or swirl continuously until there is a permanent colour change. This is the end point. Repeat until you get 2 concordant results. In the second question, this is in 2 parts. We need to be confident with the term concordant results. We then need to be confident with how the concentration is calculated. Remember those 5 steps. Step 1, balance symbol equation. Look out for this, it will be in the question. Number 2, the ratio of the acid to alkali. Number 3, the moles of known sodium hydroxide. In this case, the volume multiplied by the concentration is equal to moles. Number 4, moles of unknown. This is going to be the moles of the sodium hydroxide multiplied by the ratio of acid to alkali. And 5, the concentration of the unknown. We need our moles divided by volume is equal to concentration. In question 3, we need to know a couple of definitions. A strong acid completely dissociates its hydrogen ions when dissolved in water. The ionic equation for neutralisation of an acid and an alkali only requires us to know the ions that are involved in the neutralisation. Hydrogen ion, H+, in aqueous solution, plus hydroxide ion, OH- in aqueous solution, goes to water, H2O, liquid. This required practical needs you to be confident with the practical skills, names of the glassware and the calculations. Look at some past paper questions. Make some revision cards for the indicators and their colour changes. Always include what they were at the start and what they changed to. Time yourself with writing a method. You will only get 6 minutes to read the question, process what you need to do, and then write your answer. Thank you for viewing this Any Excuse for a Chemistry Experiment video. I'll post all the required practicals in this playlist. If you found it useful, please subscribe, click the thumbs up button. Look out for more videos to help you with your GCSE chemistry. Thank you and goodbye.